Okay, so cellular respiration, the main goal is to produce a whole bunch of ATP. And ATP stores what?
Energy.
Energy, very good. So technically, and I am going to have you flip your sheet over back to this side real quick. And you know how we had the equation of cellular respiration? We had C6H12O6 plus O2. You guys already have it written down. At the very end, okay, and I don't know if I swapped these when we first wrote it, I'm going to have you add energy. So wherever your equation is in your products, put plus energy, because that's the main thing that is being made, okay? And that energy is, of course, in the form of ATP. Okay, so back over here. So yesterday, this was step 1. And where is step 1 occurring? It is inside of the cytoplasm. So what is this big molecule that's being broken down?
Glucose.
That is glucose. Very good. And each star represents?
ATP.
ATP. The circle represents?
NADH.
NADH. I'm just going to write it. And you have 2 of them right here. DH. This guy right here, that's the stop sign. What does he represent? 3CO2, very good, which is one of the products of cellular respiration. Our triangle represents what again? ADH2, both of them do. These two, again, their main goal in the whole process of cellularization, or their part, is to give away electrons and to give away hydrogen atoms. That's their main goal. That's the reason they're made, okay? So don't let them confuse you. They're super important in the very last stage, okay? So stage 1 is glycolysis. Stage 2 is what? Krebs cycle. And we've left the cytoplasm and we've moved into the mitochondria. Very good. So now we are going to hit the last stage, and this is stage 3. Here we go. Hope you guys can see. This is stage 3, and this guy is called ETC, the electron transport chain. Okay, so I'm going to move these back and forth. All of these NADHs, which are here, 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 and your FDH2. So all of these guys that carry electrons and hydrogens are going to move into the electron transport chain, and they're going to drop off their hydrogens and they're going to drop off their electrons. Okay, so over here, you can see that we've got an electron. That electron came from NADH, dropping it off. And also, can you see how we don't have any NAD, or we don't have any H here? Can you see that? Okay, so not only has NADH given up its electrons, but it has also given up its hydrogen. Okay, so I'm going to circle my hydrogen and just kind of put an arrow right there. We need to draw one more molecule because these guys, the FADH2, they actually come in here as well. So I'm going to draw 2 triangles, and I'm going to make the first one FADH2, and I'm going to draw kind of like a produce a sign. And I'm going to make this new guy FAD. So he as well gives up his electrons and his hydrogen. So the FADH2 turns into FAD. So that hydrogen, see how there's 2 of them? One hydrogen goes here, one hydrogen goes here, and any electrons they have are going to go over here. So they literally are just there to drop off hydrogen and electrons, okay? Each of these ovals, these guys are protein channels. Okay, that one went off the chart. Each of the ovals are protein channels. They're like tunnels. You want to think of it like that, okay? This guy right here should look kind of familiar to you from photosynthesis. This is our enzyme. This is ATP synthase. And if you remember, ATP is made using that enzyme, okay? Now this next part is just like photosynthesis. So our NADH and our FADH2 give away their hydrogen atoms, okay? Their hydrogen atoms are going to flow through the protein channels, okay? Their electrons are going to flow across them, and the electrons are going to be kicked out down here. We'll eventually get to that. But I want to look at the hydrogen. The hydrogen ions flow through the protein channels, and they actually make their way into the enzyme ATP synthase. So put H plus right here. Let's see if I need to make this bigger. Oh, too big. Ooh, that's too big. All right. Stick to the original. Okay, so if you guys remember from ATP synthase from photosynthesis, remember how those hydrogen ions had to go through it before it would start working? We wrote down their gatekeepers, right? So same thing here.